Hello, everyone. We're Group 14, and this is our Phase 2 submission for the ASU Event Hub project that we selected. In Phase 1, we designed a unified platform for aggregating and visualizing ASU events. Now, in Phase 2, we're implementing the complete database with a relation schema, populated it with sample data, and also created a comprehensive set of queries to demonstrate all functionality. This video is going to be a quick walkthrough on how we set up our database schema and design, the sample data we've populated, and the queries we created to support the application.
Our database consists of 5 main tables that work together to manage events and event registrations. First, let's see all the tables we've created. Um, as you can see, we have a user table for storing student and admin information, department table for ASU schools and services, location table for event venues across ASU campuses, event table for all events with their details, and registration table that links users to events. Now, let me show you the structure of each table, starting with the user table. Uh, the user table has 6 columns. Yeah. Yeah, so here the user table has 6 columns: user ID, ASU ID, first name, last name, email, and role. Um, we have check constraints to ensure only valid roles are entered, and unique constraints on ASU ID and email to prevent duplicates. Let me show you the other tables quickly as well. So, department, that's department. The department table stores ASU schools and services. Next up, I'm going to show you the location table. The location table stores venue information across multiple campuses. And next up, we have the event table. Yeah, so the event table is our main table. It consists of the event details, capacity, status, and foreign keys to department location and the user who created it. Finally, we have the registration table. Yeah, so as you can see, the registration table is a linking table that connects users to events, allowing many-to-many relationships. Arnav will continue.
So for this one, we will be going over the user data, department data, event data, and registration data. So let's look at the sample data we've populated so far. So we have 10 users in our system, 3 admins and 7 students. We can see Alice, Bob being and George being the admins, and everyone else is just students. Each user has a unique ASU right ID, which we can see in our columns, and email addresses. The admins, we just went over them, and the other students are Charlie, Deanna, Ethan, Fionia, Hannah, Isaac, and Julia. Let's see the departments. We'll run the command for that. And here are the 8 departments we have for ASU. They represent the different ASU schools and services, including the School of Computing and Augmented Intelligence, School of Engineering, College of Liberal Arts and Sciences, and others. Let's look at the events now. Let's, we have 20 events in our systems with various statuses. Some are approved and ready for registration, while others still in process. Each event has a title, description, start and end times. Every event has its own capacity and they're associated with their department and a location. And finally, let's see the registrations. So as you can see, we have 16 different registrations showing which users are registered to which events. This linking table enables many-to-many relationship between users and events. Over to Ivan.
Now let's demonstrate the queries we've created to support the application. These queries cover all the main use cases for our event management system. Query 1, yes, you see. All right. Query 1 shows all approved events with their department, location, and current registration count. This is what students would see when browsing available events. Query 2 shows events created by a specific admin, allowing admins to manage their events. Query 3 shows all events a student is registered for, so they can see their schedule. Query 4 demonstrates registering a student for an event. This is the insert operation. Insert, yeah. Query 5 shows how an admin can approve a proposed event. This is the update operation. Query 6 demonstrate canceling a registration. This is the delete operation. Query 7 finds events by department and date range, allowing users to filter events. Query 8 finds events at a specific campus location. And all 8 queries are working correctly and demonstrate the full create, read, update, and delete operations, which are required for the application. Coming to Sahum.
Okay, so just quickly talking about the schema diagram, and what we've basically done is we've normalized our database to 3NF, which eliminates redundancy and ensures data integrity. So each table basically has a single responsibility. Also, every table has a serial primary key. What that basically does is it auto incriminates, ensuring that there's unique identifications of each record. We've also used foreign key constraints with on delete cascades to maintain integrity. So, in case a department is deleted, all its events are automatically deleted with it. We use check constraint to validate data, for example, ensuring role is either student or admin, and status is either proposed, approved, or rejected. We've used unique constraints. We've ensured that ASU write IDs and emails are unique to prevent duplicate users. Indexes, we've created indexes on frequent queried columns like foreign keys and status to improve query performances. We've also used, for the registration table, we've used a linking table to create a many-to-many relationship between users and events. This basically allows users to register for multiple events, and events can basically have multiple registrations. So this design overall ensures data consistency, prevents anomalies, and provides efficient querying for the application. That's it for our phase two. Thank you so much.